Hi. While we completed section 3.8, and that is the last section of chapter 3, there is one more thing we're going to spend some time on this week covering before we take our chapter test over chapter 3, and that is mixture problems. The reason I'm covering mixture problems now is because chapter 3 is on solving equations, and to solve a mixture problem, you're going to have to be able to write an equation out and then solve it. So the hardest thing of mixture problems is getting the equation written down. I'm pretty confident that through chapter 3 you've done a good job of picking up on the steps I wanted you to show in your work, and if you have an equation you can probably solve it. Okay, writing an equation for a mixture problem, that's the trick, okay? And this is something I think you have to understand going up front. This is not necessarily easy. And what I mean by not necessarily easy, I'm not trying to scare you. I'm just trying to say if it's hard for you to pick up a little bit at first, that's understandable. That's normal, okay? If you just could whip through this without having any problem at all, I wouldn't spend any time on it. All right, so being able to write an equation for a word problem, that's probably one of the tougher tasks of algebra. You will get better at it if you practice, if you try, and again, and not convince yourself, well, I can't do this. You just have to keep on practicing, keep on trying. You will consistently get better at it. I got a couple suggestions here for you regarding solving mixture problems. First of all, I think it's always useful to draw a picture of the situation, or at least at minimum, write out a description of what's going on in words. And I'll do that on each of my samples that I'm going to do with you today. And then you want to use your picture to write an equation, or I guess I could have put use your picture or words to write an equation. Okay? I can't emphasize how important it is to draw a picture, write out words in a description. In fact, on a quiz or test, I would give you credit even if you didn't have the whole thing right, if you would at least describe the situation properly. I would at least give you something. Okay, so the one thing we can't do is come across the problem and say, well, that's too hard, I quit. You at least should try to do as much as you can, attempt it, and if you're doing some things right, at least describing the problem within a picture or out in words correctly, I would try to give you some points. I got some sample problems for you here that we're going to work through. I got 4 of them, and this is 4 great examples of mixture problems. Okay? So here's the first problem. It says, Barrett's bookstore sells pencils for 10 cents each and erasers for 15 cents each. Last Tuesday, the store sold 17 more pencils than erasers for a total of $23.45. How much of each item were sold? So I guess the first thing I should do is let me just get out a highlighter. Let's make sure we understand what the question is. It's right here. We're trying to find out how much of each item was sold. Here are some words that would describe the situation. The pencils sold plus the erasers sold has to equal $23.45. Now, you might not think that's a big deal. Now, as a math teacher, I think that's a big deal. If you wrote that on paper, you're already starting to write a correct equation. On a quiz or test, even if you could do nothing else right, if you could at least write this down, I'd at least give you a point, because this is a correct thought. Okay, the pencils sold plus the erasers sold should equal $23.45. So now we have more to it. The pencils are 10 cents each. Okay, well, how many pencils did we sell? And I have no idea. I do know that I sold 17 more pencils than erasers. Okay, so I don't know how many pencils I sold. I know the erasers were 15 cents each. I don't know how many erasers I sold. So what I could say is, okay, let's pretend I sold X erasers. If I had 17 more pencils sold, that means I sold X plus 17 pencils. Okay, so Every pencil I sell is 10 cents. Let me write that out. It's 10 cents times the number of pencils I sell. Plus, it's 15 cents times the number of racers I sell. And that amount is supposed to be $23.45. Well, if you can get to here, I'll put this green. If you can get to here, you're probably going to be in great shape, because now all we have to do is distribute and solve. So let's do that. I should say distribute, simplify, and solve. Let's distribute. So I have 0.1x plus 1.7 plus 0.15x equals 23.45. I can combine like terms. I do see like terms. I have 0.25x plus 1.7 equals 23.45. I would definitely suggest writing these on a separate sheet of paper. You can see I'm running out of room. Okay, so I'm just going to keep on writing right through this problem. Okay, I'm just going to keep on writing right through that. So my next step, let's take away 1.7 from each side. When I do that, plus 1.7 minus 1.7 cancel out. I get 0.25x. Let me grab my calculator. 23.45 minus 1.7. That's 21.75. 21.75. And then I can divide by 0.25. And when I do that, I get, let's take that, divide by 0.25, and I am getting 87. So what I think happened here, now I got to answer the question. That has not answered the question. The question is how many of each were sold. Well, X is 87. That means I sold 87 erasers. I sold 17 more pencils. That would be 104. Now let's check to see if this works. If every pencil is 10 cents and I sold 104, 104 times 10 cents means I sold $10.40 of pencils. Maybe I'll just write that over here in blue. So I must have sold $10.40 in pencils. I sold 87 erasers at 15 cents a piece. 87 times 0.15 is 13.05. 13.05 I meant to say. There we go. And I want to check, okay, is this correct? If I add 1040 of pencil and 1305 of eraser, do I get a grand total of 2345? And as I'm checking this on my calculator, yes, I do. I just checked that. I have done this problem correctly. And can you see I have 17 more pencils and erasers like I'm supposed to? That would be an example of a mixture problem, okay, or at least a problem that would be under the umbrella of a mixture problem. Okay, here's another one. This one I think would be better served with a picture. It says Zena has 48 milliliters of a solution that is 25% acid. How much water should she add to obtain a solution that is 15% acid? Okay, so I'm going to draw a little picture. First of all, she has this first, I'll call it a jar. And in this first jar, it says she has 48 milliliters. So I'm just going to write that on top. I have 48 milliliters in here. 25% of this is acid. So 25% of this, I'll just put A for acid, okay? Which means 70% of this is something else. Or I misspoke, 75% of this is something else. Okay? We're going to take this 48 milliliters, and to it, we're going to get another glass, and we're going to add, it says here, water. So this is all water in here. Okay, so it looks like we're mixing acid and water, so that tells me that this must have been water too. Okay, so I have 75% water in my first container, 25% acid. The second container has 100% water. So think about that. How much acid would be in this container? If it's 100% water, that means there's no acid in this container. And I'm going to mix these. I'm just going to put plus because that means I'm mixing these together. Now when I mix them according to this, we want a solution that is 15% acid. So when I'm all done mixing these in my final glass, I want a solution that is 15% acid. In other words, I'm diluting this solution with all water. So I want 15% acid, which means there's 85% water in here. Okay? Now there's two parts to this I gotta be careful about. First is these mixes. Okay, so let's just go back and make sure. The first mix is 25% acid, which means it's 75% water. The second mix is no acid, 100% water, and the third mix is 85% acid, 85% water, I misspoke. 85% water, 15% acid. Okay? So that's the first issue in my picture. Here is the very important second issue. It's up here. This first container has 48 milliliters in it. The second container, how much water? Do we know how much water is in here? Now we do know it's all water. Do we know how much? And obviously the answer is no. We do not know how much water. We don't know. Okay? We don't know how much. Well, use a variable, x. Okay? Now we go to the final container. Now think about this. If the first container has 48 milliliters in it, and you take the second container and you add x milliliters to this container, wouldn't the final container have 48 plus x milliliters in it? I've added the 48 milliliters and whatever amount of this I pour in there, I'm going to now have a final container with 48 plus x milliliters. Okay? Now you have everything you need to write an equation and solve this. Now there's two ways we can write the equation. I'll do one in black, one in blue. Here's the first way. I'm going to write an acid equation. And here's what I mean by acid equation. You are going to take, let me get my highlighter out, you're going to take the acid percentages and the totals and write an equation. And here's how you do it. Very simple to do. You're going to take 0.25 of 48 because 25% of this is acid, plus I have 0% of this being acid, so 0x equals 0.15, 15% acid of the 48 plus x at the end. And let me solve this then. 0.25 times 48, I got to simplify, that's 12. This is 12 plus, isn't anything times 0, nothing? Okay, so this is 12 plus nothing on the left, and on the right, I got to distribute. I'll use my calculator here. 48 times 0.15, that's 7.2. I get 7.2 plus 0.15x. And then I have to get, I got to get everything on one side and x on the other, so I got to do two things. I got to get rid of plus 7.2, and I got to divide by 0.15. I'll subtract 7.2 from each side next. And that gives me 0.15x equals 4.8. And then I can divide by 0.15 on each side. And when I divide each side by 0.15, 4.8 divided by 0.15, I'm getting 32. So it looks like x is 32. Okay, so let's check on this one. Let's see if this makes sense. And then I'll show you the second way of doing it. So I think the answer is 32. Well, let's check. If this is 32, that means I added 48 and 32, that right now when I'm done I have 80 milliliters in here, right? That's if I'm adding 32. Now let's think. 15% of this 80 is acid. Let's find 15% of 80. 80 times 0.15. Okay, so that means when I'm all done, When I'm all done, this container had 12 milliliters of acid. Let's go to the first container. 25% of that is acid. Well, 48 times 0.25, when I put that in my calculator, that equals 12. I added no acid to the container. I started with 12 milliliters of acid. I finished with 12 milliliters of acid. This is definitely right. I added no acid to the container. My new container has 80 total milliliters of fluid in it, but the amount of acid didn't change. That means I've diluted this container. Okay, there is less acid mix. It's been diluted. Okay, now there's a second way of doing this problem. Okay, a second way of writing in the equation. So I hope I'm going to try to erase some of this here if I can. I told you that we had an acid equation that I used to solve. I could also have used a water equation. I'll do this in blue. Water equation. Well, if I do a water equation, I'm doing the exact same thing, but I'm using the water percentages now. So I would take 0.75 times 48, plus I have 100% water in this container. That'd be 1 times X. And then in my final container, I'd have 0.85. There's 85% water with 48 plus X milliliters of fluid. Okay, let's distribute over here and simplify solve. Well, over here, 48 times 0.85 is, just 1 second, I got a 0.85 times 48. Got to get this in my calculator right. So I get 40.8 plus 0.85x when I distribute here. Over here, 75% of 48 is 36. I get 36 plus 1x. Okay, now I have variables on each side. I don't want variables on each side, so I'm going to take away 0.85x from each side. And again, I'm going to run out of room, so I'm just going to continue below this problem. I'll just cross it out. We'll do that later. Okay, so cancel out. I get 36 plus 0.15x equals 40.8. And then the next thing I do is I subtract 36 from each side. And when I do this, I want you to notice something immediately. I get 0.15x equals 4.8. I want you to look at what I have here and compare it to what I have up here when I did it with an acid equation. Look what happened. I'm getting the exact same thing, which means I'm going to get the exact same answer. Okay, so this would be a great way to solve these mixture equations that involve pouring one liquid into another and trying to find out how much you poured of one into another. Okay? And you can notice it doesn't matter if I do an acid equation or a water equation using the acid percents or water percents, I'm going to get the correct answer either way. Let's go to this next one, another mixture problem. An advertisement for orange drink claims that the drink contains 10% orange juice. Jamel needs 6 quarts of the drink to serve at a party, and he wants the drink to contain 40% orange juice. How much of the 10% drink and pure orange juice should Jamel mix to obtain 6 quarts of mixture that contains 40% orange juice? So a lot of information there. So let me write down in words what Jamel's going to do. Sounds to me like he's going to take 10% drink, 10% orange juice drink. He's going to mix it with pure orange juice. I'll just put pure OJ. And when he's done mixing those, he wants that to be 6 quarts of 40% orange juice. Now, just what I wrote down here, this is a correct interpretation of what's going on here. I would give you some points. I'll give you a green for this. I'd give you some points for that, even if you could get nothing else right, because you are correctly starting to set up a problem here. Now I'm going to draw a picture of what's going on. This first container, 10% of it's orange juice, 10% OJ. So this is the cheap stuff. The rest of it's water. I don't know if you like Sunny Delight. I hate Sunny Delight, but it seems like it's watered down stuff, or Tang. I haven't had that in a long time. It's watered down. It tastes watery. It's probably one of these deals, 10% mix and 90% water. Now, when you say mix, mix means we're going to add, okay? We're going to add. We're going to add pure orange juice to this. We're adding pure orange juice. So this is 100% orange juice. Now, if it's 100% orange juice, how much water is in here? And I think you already know the answer. There's no water. This is all orange juice. When I'm done mixing these, I'm going to end up with 6 quarts. And in these 6 quarts, I have 40% orange juice, which means this is 60% water. Okay, now there's only one part of this we haven't figured out. We got the mixes, the 90 and 10, 100, 0, and 60, 40. We don't know how much of each of these are. So here's the common mistake. I'm going to put this in red because it's wrong. Here's the common mistake. I have people do this. They'll just put, well, X, Y. Well, we don't have two we don't know how to use two variables yet, so we can't just put X, Y. It's not going to work, okay? So we got to think about this a little bit. This first container, I don't know how much of this I have, so I will definitely call that X. Now think, when we're done mixing this, we end up with 6 quarts. Let's think for a minute. So I'm thinking, here's my mind, I'm thinking. If this has 1 quart, what would this be? And you're probably thinking, well, I know it's 5, because 1 and 5, 6. Well, how did you get 5? Well, it's so easy you might not even think. Since this is 1 quart, you took 6 minus 1 to get the 5, right? Well, what if this was 2? Well, then you're probably thinking, well, that's easy. That means there had to be 4 here. Well, how did you get 4? Well, didn't you take 6 minus the 2 to get the 4? What if this is 5 quarts? You're probably thinking, well, that's easy. This is 1 then, because 5 and 1 is 6. Well, how did you get 1? You took 6 minus 5. So my question is, what if this is X quarts? Well, I have to take 6, subtract X. This must be 6 minus X then. Okay? There's 1 of 2 equations you can write. You could write an orange juice equation. I'll do that first. Here's my orange juice equation. And I use the orange juice percentages then. 10, 100, and 40. So here we go. 10% of X plus 100%, 1, that's 100% of 6 minus X, has to equal 0.4, 40% of 6. Okay, well, here we go. I have 0.1x. When I distribute, I get 6 minus 1x equals 0.4 times 6 is 2.4. I need to simplify. I have like terms here and here. Well, 0.1x minus 1 whole x, that's going to give me, I got to cross this out, I'll continue under here. I have negative 0.9x plus 6 equals 2.4. I'll subtract 6 from each side. That gives me negative 0.9x equals negative 3.6. And I'll divide each side by negative 0.9. And I'm finding out x is 4. So if x is 4, that means this had to be a 2. And I can check it now. If I take 10% of 4, that's 0.4. Maybe I'll write this out in blue. 10% of 4 is 0.4. 100% of 2 is 2. 40% of 6 is 2.4. Does 0.4 quarts of orange juice plus 2 give me a 2.4? Yes, it does. Okay, so that definitely works. Now, remember I said there's two ways to do it. I'll do the second way in green. You could have written a water equation instead of an orange juice equation. Let me do a water equation, and you'll notice we get the same response. You got to use the water percentages then. I'm circling them in green. So 0.9 times x plus 0 times 6 minus x, this is going to work out great, equals 0.6, 60% of 6. Now this works great because when you distribute 0 with anything, you get 0. So I have 0.9x equals 0.6 times 6, which is 3.6. Look at what we have. We have the exact same equation, we just have our different signs. When I divide each side by 0.9, I am still getting x for a response. Okay? One last example to walk through, and then I think we've had enough examples of mixture problems where you could at least start and be able to do this, okay? Actually, I should have erased this. I'm just going to start from scratch for you, okay? At least I don't even like my picture there in some ways. I don't think we need a picture as well for this one. Okay, so let's walk through this. Rochelle has $2.55 in dimes and quarters. She has 8 more dimes and quarters. How many quarters does she have? Well, let's write this in words. Rochelle's dimes plus her quarters has to equal $2.55. That's the first issue. Okay, now here's the next thing. She has 8 more dimes than quarters. Okay, so I do know a little something about her dimes. She has 8 more. I don't know how many she has, though. Quarters, I know nothing. I know nothing about how many quarters she has. Well, if I know nothing, I'll call the quarters x. I know something about the dimes. There's 8 more dimes than quarters. I can call that x plus 8. Okay, now here's the next thing. So we have x quarters and x plus 8 dimes. Okay, now this would be a common mistake people make. They just write this and try to work this out. Okay, I'm still missing something here. Think about it. Let me just make up an answer. Let's just make up something. Pretend that the answer was x is 10. Just pretend for a minute. If x is 10, that means this is 18, right? Does 10 plus 18 give you $2.55? And you're probably thinking, no, 10 plus 18 tells me how many coins I have. Okay? So just keeping this equation isn't good enough. I want a price. I got to incorporate price into this. This is how many dimes I have. This is how many quarters I have. Okay, but we got to incorporate price. Think about it. A dime is 10 cents. So if I ended up with 18 dimes, I'd have to take 18 times the 10 cents to find out how much money I have. I got to incorporate the money. Quarters, those are 25 cents. Now, this will give me a price. Well, let's solve it. I got to distribute first. 0.1x plus 0.8 plus 0.25x equals 255. Well, now this is easy. Simplify, solve. I can see I have like terms here. Okay, so I have 0.35x plus 0.8 equals 255. Now you're going to notice this is a simple two-step equation. Subtract 0.8 from each side. Wish I could move this down more, and it's not letting me, unfortunately. Okay, so I'm going to, oh, yes, it will. There we go. Okay, so I'm going to subtract 0.8 from each side. I get 0.35x equals, let me double check my math on my calculator, 2.55 minus 0.8. That's 1.75. And now I can divide by 0.35. And when I divide by 0.35 on my calculator, I'm getting 5. Now I got to check my answer, and I'm not done yet. I haven't answered the question. Okay? This tells me we must have 5 quarters. So the answer is 5 quarters, but we should check. So I think we have 5 quarters. Well, if I have 5 quarters, I must have had 13 dimes, right? 8 more? Let's see if this works out to $2.55. If I have 13 dimes at 10 cents each, that means I got $1.30 in dimes, or at least Rochelle does, right? $1.30 in dimes. If we have 5 quarters, that's another $1.25. $1.25 in quarters. Does this add up to $2.55? And the answer is yes. Okay. So I walked through 4 questions regarding mixture problems. I'm going to stop this video now. When we come to class tomorrow, we will have a chance to practice and go through mixture problems some more.